was really cool.
Awesome. Well, hi, everyone. Welcome to another LinkedIn Live episode. I'm Jake Hall, the Manufacturing Millennial, and I'm super excited to meet with everyone here live on LinkedIn and on YouTube to really have two special guests talking about some awesome technology. So as you know, if you're joining us live, go ahead and like and share and comment so we know you are in the chat. Let us know where you're from today and who you're with so we can give you a shout out and say hi. But two special guests today are actually joining us from across the pond, actually across the Atlantic, and Vincent and Thomas. Welcome. How are you guys today?
Good. Thanks.
Well, I have to say, to start off with right now, I normally get commented on how cool of my background is with all the robots and 3D printers and cameras and gear. But what is that behind you?
Yeah, we saw your background and we felt, how can we top that? So we're based here at RDM in Rotterdam, which is the former dockyard. So we have a shipyard here in the back, built in 1914, but now it serves as an innovation dock. So we have all kinds of startups here that are working on cool stuff like 3D printing and drones and what have you. Yeah.
That is really cool. So as we're looking at, there's a lot of innovation happening all over the world right now. We're seeing how robotics, vision, all these new solutions are impacting technology. I want to start off with a little bit. Everyone knows about me. I want to know more about what you guys are doing in the industry, what your roles are. So Thomas, let's kick off with you. Who are you? What's your role? What's the company? And, give us some just bullet points on about, what we're seeing. And then we have some really cool people. We have, let's see, Saraba from Bonnerud. Welcome to the stream. Nice to meet you. Thomas, kick things off.
Yep. So my name is Thomas. I am the CEO of a company called Civid. And Civid is a pure play 3D camera company headquartered in Oslo, Norway, which is just 2 hours flight approximately from beautiful Rotterdam, where we are today. Pure play means that in contrast to other vendors of 3D cameras, we only make 3D cameras, and we're trying to develop best of breed high performance cameras. We're today a global company with offices in US, China, Korea, Germany, and about 80 employees. And the cameras we make are very high speed, high resolution, hundreds of micrometer of precision, and least but not very important, or very importantly also industrial grade. This is sort of our latest and greatest camera, and we put a lot of effort into making our cameras really small, really lightweight, to enable them to be put on the arm of the robot. So our customers, they develop robot cells, essentially integrating the camera together with robot arms, together with industrial computers, software, grippers, and these things, and really across a lot of different applications in manufacturing and logistics.
Awesome.
So while 3D cameras are sort of a generic technology, they are being used in an incredible breadth of applications, everything from bin picking, machine tending, assembly, surface finishing, piece picking in logistics, parcel handling, and then today we're going to talk about WAAM. So that's a really interesting use case, I think.
Yeah, no, that's fantastic. So let's welcome some of our other audience members. We have Carl from Quebec City. We have Ryan from Austin, Texas. Ian from Toronto, Ontario. We have Muhammad from Pakistan. Welcome. We have someone from Dallas, France. We have everyone from Dallas as well, another from Hong Kong. So we are truly all over the world right now. So thank you guys for joining us today. And, as we're talking about everyone coming together, we're also talking about a lot of new technologies coming together, which is why Vincent is here at the table today. So Thomas says you were talking about how the Civid can impact and work alongside robotics. That's the solution that kind of Vincent and your team. So Vincent, let's get an introduction from you.
Yeah, sure. So Vincent Wegener, I'm co-founder and managing director of RAMLab, which stands for Robotic Additive Manufacturing Lab. And for those who just joined now, we're based here in the former dockyard RDM, and this is now a place for innovation. So it's a big playground. I think you'll love it here, Jack. Sorry. And we had a makerspace before we started RAMlab actually. So my previous company was a makerspace, like a tech shop you have in the US or had in the US, and that's how I started in 3D printing actually, like just the plastic printers, and now we do metal printing here.
And that's really exciting. It's amazing to see how much additive manufacturing and 3D printing has evolved over the last 15, 20, even really the last 24 months have really been spectacular to see the evolution. So let's get back to that. But first, let's dive into more talking around the lines of how vision has been impacting the industry over the last 3 to 5 years. You know, Thomas, let's go back to that real quick. How are you seeing vision changing our industry?
Yeah, so 3D vision, or let's say advancements in 3D visions over the last years, have played a really, really key role in the rapid rise of robotic automation. And I think it really boils down to three things. That the combination of robots and integrating 3D vision into them is rapidly expanding the type of tasks a robot can perform. And in other words, enabling a host of new applications for robotic automation. At the same time, just equipping these robots with 3D vision also for existing applications that are possible without 3D vision, there are ways to take advantage of that vision to make them faster or more reliable. And the third thing, and not to be underestimated, is that with 3D vision, we can significantly ease the deployment of robot cells and the maintenance of robot cells. And we can also make these robot cells significantly more flexible to adapt to different type of work spaces or different type of parts. So I believe that sort of the impact of 3D vision is really not to be underestimated here. In the bigger scheme of things, I believe that we're just getting started in terms of what we can do here and what we can make possible. And with now this rapid emergence of 3D in combination with cloud computing and AI, we are nearing now an inflection point in terms of those things hitting and providing really a second growth curve for robotics.
Now, Thomas, do you think we're seeing such a transition in the manufacturing industry as a result of 3D vision becoming more popular because of the demand for flexibility, where it's no longer just something where we're producing thousands and hundreds of thousands or millions of the same parts? We need 3D vision because it provides more flexibility and changes with a dynamic working environment?
Well, I think it's, if you think about the first or most simple use case in manufacturing for 3D vision, that is bin picking. It's essentially singulating parts from a bin and putting them on a conveyor belt. And that's a very, very sort of, it's a type of task you have in almost every type of manufacturing facility. So I think those things together with sort of assembly and so on has sort of driven 3D vision to where it is today. But we're getting to a stage where the availability of these cameras, the price points, the quality, the ease of use has come to a point where they are being picked up and being used, and there are new use cases emerging very, very quickly. So I think there is, sure, it started on the bin picking side, and now we're seeing this incredible lot of innovations on how to use this technology also for other tasks.
So let's talk about one of those tasks as well. Welcome, everyone. It's amazing seeing, literally, I think we hit every single continent. We have a viewer, besides Antarctica, a viewer watching us from right now. So that's pretty exciting to have here on this chat today. And as we're talking about vision, we're talking about robotics. I encourage the audience here, if you have questions about 3D vision, you have questions about integrations with robotics, and if you have questions about what we're going to be talking about really quickly with Vincent with WAAM, and Vincent, I'm going to have you discuss what is WAAM. You know, please put those in the chats. This is a conversation meant to be had with the audience. This isn't just a presentation. We want to have interactions with you. So if you have questions, we have two industry experts here today with us. Let's make sure we leverage that time. So Vincent, what is WAAM? What is Wire Arc Additive Manufacturing? Let's talk about it. And I got some videos to better explain that too.
Yeah, sure. So Wire Arc Additive Manufacturing, or for just to keep it simple, 3D welding, because what we're doing is just weld layer on top of each other to create a 3D shape. It's a bit more sophisticated than your average 3D printer, home 3D printer. But that's the process. So it's a metal printing, and that's what you see here. So we're printing a part, and on the right you see the Zivet scan projection. So we're, like I said, laying layer on top of each other, making big parts. So a bit of the origin story here of RAM Lab is that we're based here in the port of Rotterdam. We started with a vision of like what happens to a world where supply chains are disrupted and you don't get your part in time. That was 5 years ago. I think it's more relevant today, of course, than ever. Let's transition to a digital warehouse where you can just pick a part like a Spotify. You pick a song, you print your part when you need it, where you need it. But if you want to build big parts, you need a big machine. You need a lot of kilos an hour. And that's where this technology comes in, really. So we started 5 years ago. Perhaps later on we'll show some examples of what we've printed. But then, we really found out like what's the key component to make certified parts. So that's the key here, of course, in the port area where you have oil and gas, maritime, offshore. Every part that goes on a ship, goes into an oil well, has to be certified. You have to show quality. And that's where we really focused on the last 5 years, is really to how to produce quality parts. So not only the vases or what have you can place in your home, yes, but really like make parts that are actually used by the industry. And that's where our vision comes in, combined with some other sensors we have equipped on the torch and on the back end of the robot, so we can let that machine run 24/7 basically. With the help of the 3D scanner, with temperature sensing, with current and voltage sensing. So that's what we have built, and we also what's called MaxQ, and we can apply it to both printing of parts, metal parts, but also repairing of parts.
Okay.
Perhaps you can show that the video later, but that's one of the
absolutely. What that's an exciting case study. So let's hit that in a second. From the audience here. I would love to know who has had experience with additive manufacturing, if it's from a 3D printer, or if you that's just printing some plastic, or if you are printing with metals and other materials. I'd love to know that. And, really quickly, I'd like to, Vincent, let's go into more detail specifically about, there's a lot of standards, there's a lot of quality checks. What I think is really interesting is the diversity of materials that we're able to weld with now.
Yeah, exactly.
Can we talk more about the diversity of materials that you're seeing and why that matters in this space?
Yeah, so we have a broad range of welding wires. I think everybody's familiar, of course, with just regular steel, construction steel. That's actually at the lower end. But as soon as you want to have more quality parts that are used in oil and gas, you have to have a higher grade of steel, like X90 or 690. They have more exotic materials like titanium, for instance. The propeller we printed is made of a copper bronze. Mm-hmm. So basically all welding wires can be 3D welded, 3D printed, if you will. So there's a whole variety of applications, and that's also the opportunity of WAAM, is that it can be really applied to different use cases for both maritime, offshore, oil and gas, aerospace. So it's really broad usability.
Yeah, absolutely. I'm going to turn over to a question for you, Thomas, real quick. So one of the questions that we had was, can we measure profile dimension with the help of 3D vision?
Absolutely. And I think measuring those dimensions, and not only dimensions, but actually looking at very fine variations in surfaces is correct. One of the key things that sort of our camera brings to the table here. So it's well beyond measuring. Maybe you can speak to sort of the tolerances you're working on.
Yeah, so for us, it's very important. So just perhaps to dive into how we use the Zivet and why we use it. So when we're welding, basically it's a molten pool of metal, right? So you're depositing a molten pool and then the next layer, and that means like you have these deviations in your surface. So every layer we have to correct for that. And that's why we use the scanners to have that. We scan the surface and then project next toolpath on top of that surface, and so on and so on. If you don't do that, you get deviations in your stick out. Yeah, that's the video I need. So you need to have, if the red in the video means that there was a deviation from the toolpath that CAD/CAM software provided versus reality. And that means that if you look, white means you're on par with the toolpath, red means you're not. So as you can see, almost every layer has to be compensated and has to be corrected. And so without vision, you cannot do that. It's very, there are other ways. We actually looked, of course, to other alternatives, but you really need that scanner. And we looked at, we're now 5 years in. I can tell you, we looked for 2 years to a suitable solution where, photogrammetry or other types of scanners where you have a line scanner, or those cannot handle the reflectivity, or they're too bulky. Perhaps these scanners where you have to use these stickers on top of the surface. That cannot be done in a manufacturing setting, in a production setting. So that's how we came to the Vivid scanner, and as you can see, the size. It's like amazing. We started with the Zivit 1, which is like twice the size, and we were already amazed. But now it's like so small, so light, so you can actually attach it to the torch of the welding robot. So there are many advantages to that. It can also handle dust, at the price point. So that was really just for us like wow, there's finally something that we can integrate into a welding robot, and now we can actually do this correction of the layers. That was the starting point of the problem, actually. Yeah.
So we talked about when we look at these applications, we want to reduce the risk as much as possible during these manufacturing operations. One of those is we're continuously scanning to be able to then adapt for variations within our weld. What are some other risks that we're able to address when we're using these type of solutions?
Yeah, you can imagine if you're printing parts of like 200, 400, 600 kilos, and find out afterwards that somewhere in the middle of that part there is a defect, right? So it's horrible. Even if you find, if you're 10 minutes too late, you have to grind back. It's horrible. You have to do repairs. So you want to control the part while you're welding, and that's the main thing. Is like the big risk. If you don't have that vision, if you don't have the other control we've built in, you don't get a certified part. So you have to throw away your part. That's the biggest risk, and that's mitigated with this solution.
And so, Thomas, going back to you real quick, when we're looking at vision systems, I think it's important to make the communication or the way you're outputting your data to be accessible and for integrators to use. Can you talk more into when you're designing your products, why is it important to not just necessarily keep all of your information internal, but to be able, can you talk more about how companies like WAAM Lab are able to access your data in your point clouds and be able to make decisions and integrate those into their processes?
Yeah, well, it may not, there are some complications around it, but in essence, this is a camera. And what comes out of it is like a 3D image. It's like an image you take with your DSLR, except that it's a point cloud. And that means it has 3 dimensions. It's X, Y, Z. And in case of our camera, it has RGB. So there's also color on the point cloud. And that's sort of where our job ends, is to provide the best, accurate, high precision point clouds in very little time. We do a lot of the point cloud processing, sort of the raw data is coming from the camera, and we do the point cloud processing on an industrial PC, and our SDK is typically being built into the application software our customer uses. And there's some really easy to use APIs, so you can sort of
Extract.
trigger the camera and get hold of the point cloud, and then the computations or analysis and sort of acting on that point cloud is all in the domain of the application.
You know, I want to pull up real quick. I didn't talk about this beforehand, but this is actually a really fun example of. So I have some Lego minifigures is what I carry around. So this is actually my Lego minifigure that you can see was scanned in that 3D point cloud.
Yeah. So I think part of the story, one of the things we do is that even though, you know, in the real application setting, our software is built into the, you know, the main application, but we have a Civid studio that makes it really easy for people to sort of take our camera and point it at, let's say, a relevant part that they're interested in seeing. Can we get good enough data? And I think the start with RAMLab was a colleague of mine that was at a it was a trade show in China.
Yeah.
And you saw our camera, and then you brought over the propeller.
Yeah, exactly. Yeah, so we were looking for a solution for so long. It was like we have to meet a Norwegian company, like the Dutch company. We have to meet in China to find the solution that we need. So it was a very nice coincidence. But that's like we had our big propeller there and a smaller version. So it was on the spot. I tested like if this can handle this reflectivity, then we're gonna work together, and it did. So that was really the starting point of our collaboration. And,
well, let's talk about one of your case studies. We're talking about this propeller. Let's talk about what we're seeing here as your first case study. What is this application? What are we doing? Why is it so unique? And I guess also address what's the problem in the industry that you're addressing with a solution like this?
Right. Yeah. So let's start with this video. So this was the propeller we made in 2017. And it was really the starting point for us to show the industry that you can print big parts, that you can certify metal parts that you print. So it was a great collaboration here with the industry, the local industry here, and that was really the starting point. So what you see here, layer on layer on top of it, we're welding, and then we have a propeller of 250 kilos. It took us 10 days, 24/7, and this was without our monitoring control, because then we found out, like, if you want to print these parts and you have to do 24/7 production, you need to automate the process. You need to monitor and control the process. So that was really our starting point. And also by working with class bureaus, like how do you certify parts based on data, right? So how can you show based on data that your part is really has no issues, has no defects, instead of basically destructive testing, and if you print one part, you have to destruct one part. It's not really useful. So that was the starting point. Like, how can we show the industry that you can print parts and show that with the data that you can actually get that quality that they need.
And what was the manufacturing process before this? Just so people are aware, if we had this massive ship propeller that needed to be manufactured for a very large cargo ship, what was the process before? Where was that manufacturing done? How long did it take for that product to even get to then the facility where they needed to switch it? Let's dive into more of beyond just the process itself.
Yeah. So normal way of making a propeller is to casting, right? You use casting process, and also forging. Well, it's not for propellers, for other parts of forging, also a popular process. And the belief was before we started, like, it can never compete with casting, it can never compete with forging. But what we actually see is that the quality is much higher than a casting. Like, casting has all kinds of issues with gas bubbles and porosities. We don't have that issue because we control every droplet of the welding process. And now we even see that we can compete with forging. So, WAAM is not the answer for everything. Casting and forging will still exist, but specifically if you need spare parts, if you need them on time, if you need them locally, quickly made, then this is the technology to look into. And that's actually what our customers are also using. So we have an oil and gas company, Valurec, that actually prints these parts on demand for their customers, and they use our system to control the quality.
No, that's great. I think what we could do next is this actually ties into a question that we just had from the audience. John, who is actually the president of BattleBots on TV, had a question that came in and said, "Can the solution be helped to help build and repair robots for a TV show?" Now, maybe not repair robots on a TV show, but let's talk about how this can be used for repairing applications.
Yeah, definitely.
And I think that we could tie that into the next one. So, John, maybe not quite yet for your BattleBot show, but we're getting there.
Depends on if they have these, these pointy things that have to be welded back or something, like these the spears on top of these BattleBots. But yeah, perhaps you could show that video. This is our Cobalt solution specifically made for repair of parts. So repair is mainly welding back a die or another shape back to its original shape. So that's what we're doing here. So again, we're scanning the part and then we're projecting the layer to weld it back to the original shape. And you have to imagine that currently this is all done manually. So you have a manual welder. You have to preheat the die to 400 degrees Celsius in this case, and you have to stand above this hot die in the fumes, welding that back. So it's not pleasant work. And we really see an application there where we can help the welder with this Cobalt solution, where he can still monitor that process, but then he can perhaps have multiple dies welded back at the same time and monitor that process. So now that's our repair solution.
So Vincent, does this work where the operator needs to know ahead of time of like what the original die looked like in CAD, and then it compares the current to what they would call the nominal model, and then find out what the variation is, and then that's what they're repairing and welding?
Exactly. So we use the scanner to scan the die in the shape, in the current shape, and then we compare it with the CAD, and then we generate the tool pass, and then we weld it back. So again, that's where the scanner comes in to scan the whole object and to start to have a base to start on.
Awesome. So when we look at this, cool tool, very, very cool applications that we just saw for repair, and then also for brand new parts that we're building, in this case, the marine shipping industry. What are some myths that we're wanting to address around either wire arc additive manufacturing or within 3D vision, where people might be skeptical to say, oh, that type of product, that type of solution is not for me because it has these type of complexities or it has these type of risks? What are you hearing in the industry that's going to be the most commonly addressed that you want to talk about today?
Yeah, so in general for WAAM, when we started, it was like it cannot be done. Of course, it's like new technology. Everybody's like it cannot be done. You cannot print a propeller. Then it was, of course, you can print a propeller, but you cannot certify it. Okay, yeah, now you've printed it and certified, but it cannot compete with and then it goes on and on. So it just continuously we're breaking myths here. And I think like I mentioned to say, well, we cannot compete with conventional methods like casting or forging. Well, we have shown that there is a case for that. Of course, like there is a case for spare parts. There is now the case of supply chains issues, getting your parts from China or wherever. So there is a case for local production. And so I think we scattered a lot of, or how do you call it, destroyed some myths in the past, and we'll keep on doing that. Yeah.
And so what are some other industries that you see could, drive that, have value driven from this type of solution? We're talking about large parts, obviously a propeller that weighs hundreds of pounds and kilograms. That's massive. I can't imagine the type of mold or casting you would need to make a part that big. But what are some other industries or products out there that you think end users can start using this type of technology with?
Yeah, so I really think like the oil and gas is a specific market where there's a big need for spare parts, and combined with local production. If you have issues with customs or your part is stuck on a ship somewhere on the ocean or in the Suez Canal, where have you. So that's where we see the first customers, first applications, and then. But also, in offshore, so you see printing of hooks, for instance, instead of forging hooks, you can also print these hooks, and repair. So repair is a huge case it's not as sexy as 3D printing, perhaps. Like it's more on the front end, but repair is like it's a huge market, and where we really can help with our solution.
Awesome. Thomas, what about you? 3D vision. A lot of people are still skeptical about it, where it might not be as easy to program, easy to train. It might not work in dynamically changing environments. The parts have to be very specific. What are you seeing in terms of the people who don't like the idea of this type of solution yet?
Well, let's take this case first, because I mean, this is a precision measurement instrument. It's calibrated. It has a 0.2% dimension trueness, measuring surfaces to 100 micrometer precision. Now the question is, can you put this camera in, and can it perform in a really demanding application? Like it doesn't almost get worse than what we just looked at, right? Yeah. With the heat, dust, with the big robot, with vibrations,
fumes,
with fumes, with light, and so on. It's a very challenging applications, and I think sort of it can, and we've sort of proven it together with the RAM Lab team that it's possible. You could see that RAM Lab Vincent and the team has put a casing around the camera, and that is, I think, mostly, correct me if I'm wrong, is just to protect from fumes coming in that would stick to the cover glasses as part of
spatter.
it. Yeah,
you don't want to have spatter on your lens, so that's why we've made that solution. Yeah.
But I still remember the day, my colleague told me that, okay, RamLab they're starting this 24/7 test cycle where our camera is going to be part of just printing these large parts. Yeah, and of course it needs to keep its accuracy, and it needs to work throughout this process. And I mean, what if something goes wrong with the camera when you're at the end of printing the propeller, right? So it's a big responsibility. So I think sort of we've shown that we can actually put precision measurement in instruments into one of the most dirty and demanding type of robotic applications I could think of.
No, it's awesome. It's like so we got the Zip 2 last year. It was like, compared to the Zip 1, it's like, how did you manage to make it even smaller and lighter? So it was really a pleasant surprise. Yeah.
One of my favorite books out there is called 7 Eves, where it's this idea of how we're moving manufacturing into space and moving different areas. And like immediately I think of, well, this is cool. Instead of having to ship literally hundreds of thousands of parts to a new colony, you create a system. There's actually a 3D printer on the International Space Station right now.
Yeah.
But I eventually seeing like either on the moon or on Mars or another location is, if you need complex components, you don't ship those components. You just simply ship the manufacturing system and the raw material, and you can make whatever you want then in space or on Mars.
Printing in space. Yeah, that's amazing.
That's next.
I think it's exciting. I think it's exciting to think about.
Send out to the moon. Yeah. 100%.
So as we get things wrapped up, is there any other questions, Vincent or Thomas, that you wish I asked you, talking about either 3D vision or within, a WAAM technology?
Good question. You first. Can we get some more questions from the audience?
Yeah, of course. And, the audience as well. If there's other questions, we would love to have you guys be a part of the conversation. I think one of the other things that I've wanted to talk about. Go ahead, Thomas.
I have a question. So what's next? What's going to be the next step? I mean, now we are able to do the propellers. I'm asking you, Vincent.
Right.
What's the next thing we can do, and how can we make this even better?
Yeah. So our mission really is to make it. It has to be so easy, as we always say. Push of a button, and you have to make the system works. And as we go into repair cases, and we want to expand, of course, with our product worldwide, we have to make it as easy as possible. Really to democratize the process of 3D printing and repair. So this really helps with that, making it smaller and at that price point, but really to to just have a die, for instance, and just say scan, click, repair, click, right? That's where we want to go. That's our vision.
Well, I think it's interesting you bring that up. One of my neighbors down the street, he is a professional die craftsman or repair guy, and he talks about his industry where he works with, I think, 15 or 20 other die makers, and he says the youngest die maker there is 47 years old.
Yeah, exactly.
So as we see this industry that is massively, getting older and retiring, I think we need to look at how do we repair dies? How do we fabricate new components in a way where maybe you don't have the same people with those skilled trades that are available anymore? So you need to leverage technology to be able to address those problems.
Exactly. Yeah.
And that's not even considering just the price of raw material these days. So then you have to repair, you have to reuse. And I think this is a key enabler to do that at a larger scale and do it locally.
So this is another question that for you, Thomas, from Hank. Not 3D welding, but I have a food industry acquired to place chicken pieces on a line in the same direction every time. Given how different legs and wings, etc., can look, can 3D vision be configured to allow for these variations?
Okay. Yeah.
Absolutely. I'm convinced, and I can assure that imaging chicken pieces is way easier than imaging the type of material that Vincent and his team is imaging.
That car company with the tires, right? You told me about.
So Thomas, how would Hank be best to follow up with the Zivid team?
Contact Zivid on LinkedIn, and they'll get back to you very quickly.
Perfect. So reach out, or Hank, message me afterwards, and I'll get you in touch with the Zivid team. I guess as well for you, Vincent, if people want to learn more about the solutions you're providing and robotics and wire additive manufacturing, how do they reach out to you and your team?
Well, you're of course welcome to visit here in Rotterdam, in our beautiful RDM. Visit ramlab.com. We have all the information there. Or reach out to me on LinkedIn.
Fantastic. Awesome. Well, Thomas and Vincent, thank you guys so much for joining me on LinkedIn Live today and also on YouTube. We had a great attendance, a lot of good people showing up. And once again, I'm still blown away by how we can have such an audience literally spread throughout the world coming together to learn about these new technologies. It is very exciting. And there you go. Marie just put a post in there as well. info@zivid.com is how you can reach out with that question. But until next time, I hope everyone has a great rest of your day. In this case, where you guys are, have a great rest of your evening, because it is 6 p.m. over there right now.
Yeah.
Awesome.
So,
and for me, my day is
just
starting. Fantastic. Well, thank you everyone for joining us. Of course, if you want to go back and watch this again, it will be available on LinkedIn. It will also be available on YouTube at the Manufacturing Millennial on YouTube. And of course, Zivid and RamLab will both have these presentations as well if you want to follow up with them. Oh, we do have another question. How difficult is it going to be to integrate this camera to an existing welding robot?
Yeah, so we, if that's for us a question,
I guess Thomas or Vincent.
We have MaxQ integration, so we have turnkey systems for standard Cobalt and welding robot. But if you already have a welding robot, we can integrate MaxQ in there. So I would need to know the brand and the weld source, but that's something we can provide. So if you reach out to us on our website, fill in a form, I'll go back to you.
Perfect. Well, there you go. And then, I think that's a great to point out. This isn't just industrial robotics that you need to work with as well. It's really brand agnostic when it comes to the robot manufacturer. Oh man, I think we're getting the light turned off. So I think that's a wrap. But
it's coming up again.
I think that's a close.
We're sitting still too long.
Well, Samir, go ahead and reach out to the Vincent and the RamLab team, and they'll love to get back with you. But until then, thanks for watching, and we'll see you on the next LinkedIn Live video. See ya.
Right. Thanks.